All right, so the next thing up here is the ratio test. Of course, when we were first learning these things, something we spent a lot of time on was, okay, when do we use these different tests? And ratio tests sort of stood out when exponentials and or factorials were involved. Honestly, for this year's test, it's not as important because there aren't really many other tests that are eligible for this year. So I mean, we know the integral test, the nth term test, the comparison tests are out. So it's probably going to be the ratio test, and we've got so there are those basic series that we're on the lookout for: geometric series, p series, in which case you should sort of know by looking. But otherwise, if it's a little bit more complicated one, you're going to look at the ratio test. And what's the ratio that you're interested in? It's the ratio between the n plus first term and the nth term. And you get to ignore all the negatives. You're just taking the absolute values of that ratio, and you see what happens as n gets big, and 1 again is our key value. And basically we're seeing if this behaves sort of like a geometric series, so the cutoffs are similar. If that ratio, that limit, comes out to be less than 1, then it's a convergent series. If it's greater than 1, then it's divergent. And you may remember, we used to talk about the fact that it converges absolutely. And on this year's test, that doesn't really matter, right? They took absolute convergence off. So at this point, we're just concerned that it converges or diverges. The cutoff is 1. This probably won't happen a whole lot this year, again, because we don't have any backup tests. But technically, when L equals 1, it means you chose the wrong test. And usually then you'd go to a comparison test. But in this case, we don't have that option. All right, let's look at a couple examples. So here's my exponential. At first glance, you might think, oh, this is geometric. I'm just done. But it's not geometric because of this n out in front, right? So this is counting up also, which seems like it might be big enough of a deal to make it a divergent series, even though it looks sort of like a convergent geometric. The ratio test is what will tell us what's going on. And so make sure you always, always, always write out this limit. You have to be taking a limit when you're doing the ratio test. You can put the absolute value here. In this case, there are no negatives to worry about. And so the n plus first term, you just get by replacing the n's with n plus 1. And then the nth term is the nth term, just leaving the n's. And then we just sort of do some algebra. In this case, there's not a whole lot. We've got something to the nth, something to the n plus 1. There's one more on top. And so when I clean that up, I'm basically just left with a 2/3 on top. And be careful on your algebra. You cannot cross out these n's. That plus 1 sort of messes it up. But this is where the calculus comes in. We can do the limit. If you want to write it out in a little nicer way, that 3 can go to the bottom. And so I'm going to have 2 times n plus 1 and 3 times n on the bottom. I know everything's positive. I'm just going to stop with the absolute value. And so now first degree on top, first degree on the bottom. Look at that ratio of lead coefficients. It is 2/3. 2/3 is most definitely less than 1. And so we can say it converges by the ratio test. All right. And so you want to make sure you're showing that limit. You want to make sure you call out what tests you used. You want to make sure you show your work. You want to make sure you show that you knew what you were checking. You wanted to make sure you showed that that limit was less than 1. Factorial comes up quite a bit with the ratio test. The setup's still the same. The n plus first term divided by the nth term. And now we typically end up inverting and multiplying. And so that top fraction stays the same. Whoops, that's n plus 1, right? Factorial, sorry about that. The bottom fraction flips over. And then again, we're looking for some algebra. And these exponentials cancel, so leaving a 3 on top. Remember how factorial works. This is all the numbers from 1 up to n being multiplied. This is all the numbers from 1 up to n plus 1. And so, of course, they're all exactly the same except for that n plus 1. And so there's going to be an n plus 1 there. If you don't remember doing stuff like that, here's a little scratch work. So like if I had 6 factorial over 7 factorial, n over n plus 1, 6 times 5 times 4 times 3 times 2 times 1, 7 times 6 times 5 times 4 times 3 times 2 times 1. Everything cancels out, leaving me with a 1 on top and a 7 on the bottom. So same thing here, that n plus 1 is left on the bottom. And now, of course, when n gets big, we get a limit of 0. And if you're sort of remembering some of the stuff we did before, when we were doing something called the limit comparison test, 0 was bad news. But with the ratio test, 0 is perfectly good news. It is less than 1. And so this one would also be convergent by the ratio test. So ratio test is sort of a fun one. People usually don't have too much trouble with it. Just remember you're always taking that limit of the ratio.